In this video, I'm going to discuss continuous random variables. Here are some important definitions that I need to go through before I start discussing this in detail. So, a random variable represents a possible numerical value from an uncertain event, which could be an experiment. Discrete random variables produces outcomes that come from a counting process. For example, the number of classes that you're taking. Continuous random variables produces outcomes that come from a measurement. For example, your weight. So, here's an example. Consider the following data for masses of 5 kilogram bags of rice. So, you've gone to a grocery shop, for example, marketplace, and you weigh all those 5 kilogram bags of rice, and then you group them. The ones that are 4.9, you count them, you find that they are 12. 5 kilogram exactly, you find that they are 16. 5.1, you find that they are 20. 5.2, you find that they are 14. So the important thing here that you have to know is this. Not all data labeled 5 kilogram has a mass of exactly 5.1 kilogram. A bag with a mass of, and this depends on the instrument that you're using to measure. A bag with a mass of 5.1358 or 5.0879 will be counted in this category, because if you round off that figure to one decimal place, you'll end up with 5.1. So when you collect continuous data, we have to put in groups to end up with grouped data. We can represent this information on a frequency histogram, whereby the y-axis is the frequency, and then you have the class intervals in the x-axis, or just the weight in classes. So you can represent this data in a frequency histogram. Now, suppose you weighed 100 bags of rice and created something called a density histogram. I'm going to explain what that is right now in this page. To create a density histogram, you draw a rectangle for each class with the class interval as the base and the height equal to frequency of each class. So basically, each of these bases here, below here, each of these bases will be the class intervals, and then the height will represent frequency density. Now, how do you get this density? Now, to get the density, you get the frequency of each class, right? So you get the frequency of each class, this, divide by the number in the sample, for example, in this case, 100, multiply by each class interval. So alternatively, what you can do is we can arrange this equation to have this frequency divided by number in the sample. Now, frequency of each class divided by number in sample gives us what we call relative frequency. Now, relative frequency is basically probability. This is basically probability for each class interval. So this is probability. Okay, so if you're conducting experiments, relative frequency is basically probability. Did I write this correctly? This is probability. All right, good. So that's basically probability. So basically, this formula here is simplifying to this. It's simplifying this bit here. So this is what density is equals to. So your density, what's going to be on the y-axis is relative frequency divided by each class interval. Well, actually, once you do that and you get your values right, um, the resulting density histogram may look something like that, whereby on the x-axis you have your class intervals, and then on the y-axis you have your density, which is basically relative frequency divided by each class interval. Now, what if we decrease the length of the class interval? So if we decreased the length of each class interval on the density histogram, then the density histogram will look something like this. All right? Because you have smaller class intervals. How about if we push this further and decreased the intervals even more? You can imagine that the intervals will eventually get so small that we could represent the probability distribution of x not as a density histogram, but rather as a curve. All right? By connecting the dots of the tops of the teeny rectangles. And then you'll end up with something like that. You end up with a function. All right? Now, this function here is what we call probability density function. So that function that we have there is what we call probability density function. And it's very important. So you might recall that the density histogram is defined so that the area of each rectangle, right? So the area of each rectangle is equals to the frequency density multiplied by each class interval. All right? So basically what I'm doing here is rearranging this formula. I'll go back again and show you this formula here. So if you want to find the area of each rectangle, it will be equal to, because we said this is equal to the density. So if I multiply the density multiplied by each class interval, density is what is on the y-axis, and each class interval, I'll end up with frequency, relative frequency, which is basically the probability. So that's where we're heading. So back here, so area of each rectangle will be equal to frequency density multiplied by each class interval, which gives me the relative frequency of the corresponding class. But the relative frequency is basically probabilities. And we know that all probabilities are to 1. So which means that the area under the curve is 1. It's very important. Okay, so now that we have an idea of what's happening here, let's try and define this in a different way. So a random variable is said to be continuous if there is a function y is equals to f of x with the following properties. All right. So first of all, the domain is all real numbers. So the domain is all real numbers. Range is function is above the x-axis. F of x is greater than or equal to 0. And the area under the curve is 1. Now, the fact that the total area under the curve of y is equals to f of x is 1 for all x values of the random variable tells us that all probabilities are expressed in terms of the area under the curve of this function. And we'll look at that in this example here. So this is just a general example to give you an idea of what's happening. So if x are values on the interval from a to b, then the probability that x is between a and b will be equal to the area under the graph of y is equals to f of x over that interval, which is represented in this diagram here, in this graph. So because all probabilities for a continuous random variable are described in terms of the area under the probability density function, It means that the probability that x is equal to a specific value of x, for example, x is equal to 2, will be 0. Why? Because the area of the probability density function for a single value is 0 because the width of the interval will be 0. Remember, we're looking here in terms of intervals. Right? Now, I showed you the formula how to calculate it, to calculate the probability. The area of a rectangle, which means is the class width multiplied by frequency density. Now, if we're considering a specific line like 2 on the x-axis, it won't have any class width. The class width will be equal to 0. So this basically means the probability that will end up will be equal to 0. And one more important thing is for a continuous variable, it does not matter whether you used strict inequalities like this one or like that one. It does not matter. You'll end up with the same answer. So when you're writing it, when you're writing your probabilities, you can either use strict inequalities or inclusive inequalities. Good. Some properties of probability density functions. For a continuous probability density function, the mod is the value of x at the maximum value of f of x on the interval that are given. So mod is the maximum value of f of x. The median is given by this formula. Okay. And then basically the mean is given by this formula again. It's in your formula booklet. And the variance is given by this formula here, which is in your formula booklet. We'll apply all these formulas in the examples in the next pages. Okay? So, number one. A continuous random variable has probability density function given by that. When x is between 0 and 1 or 0 otherwise. So, find the value of k. What we'll start with is to try and just sketch this graph to see how it looks like. So, just gonna try and sketch it. This is basically a quadratic function, something like that, between 0 and 1, so it stops there. And what you're saying here is the area under the curve gives us probabilities. That's between 0 and 1. And we know that area under the curve is equals to 1. So I'll start by writing this integral 1, 0, kx with respect to x is equals to 1, which will be equal to, if you integrate that, work that out, that will be k over 3 is equals to 1, which means that k is equals to 3. So we've already found out what k is, and then we can move ahead to work out the probability of x being between 0.2 and 0.6. So b, x is between 0.2 and 0.6 will be the area under the curve between 0.2 and 0.6. So that will be and if I plug 3 into this, I'll end up with 3x dx. If I integrate that, I'll end up with x cubed, and my limits are 0.6, 0.2, which will give me 0.6 cubed minus 0.2 cubed, and that will be equal to 0.208. Good. Number 2. Now this question I'll use a calculator. So this is a GDC calculator, GDC question. If a continuous random variable has PDF given by that, find the expected value and the standard deviation. So the first thing is the expected value using the formula that I showed you will be equal to the integral 20 x multiplied by whatever I have there. So 3 over 4 x into 2 minus x dx, which is integral of 20 3 over 4 x squared into 2 minus x dx. If you plug that in your calculator, so go alpha window number 4, the limits are 0 to 2, 0.75 3/4 x squared bracket 2 minus x close the bracket dx, and your answer will be 1. So my answer will be 1. The variance, that will be using the formula in your formula booklet. So x squared multiplied by 3 over 4 x into 2 minus x dx, which will be equal to, and by the way, this is minus expected value squared, so minus 1 squared. Don't forget that. So that will be integral of 0.75 x cubed 2 minus x dx minus 1. Now if you plug your graph in your graphing calculator, just plug in that integral the way I did, you'll end up with 1.2 minus 1, and your answer will be 0.2. So in the question they're asking for standard deviation. So I'm just gonna create more space here and say, so standard deviation will be equal to the square root of 0.2, which is square root of variance, which will be 0.47447. All right. Number 3. This is also a calculator question. If f of x is given by that continuous distribution function, find the median and the mode of x. All right. So the first thing that I'm going to is to find the median. I'm going to find the integral. So basically the integral from m to 0, that will give me an area of a half. So basically 4x squared minus x cubed dx is equals to a half. So I can factor out 3 over 20 because this is a constant. Then I just end up with a simpler function to work with. This is m0. So if I integrate whatever that's inside the integral, or if I integrate the integrand, I'll end up with 4x cubed over 3 minus x to the power 4 over 4. M0 is equals to a half. So 4m cubed over 3 minus m to the power 4 over 4. What I'm going to do here is, so if you plug in 0, you just get nothing. If you plug in m, you end up with this. But now this 3 over 20, I'll take it to the other side so that I'll end up with 1 over 2 multiplied by 20 over 3, which will basically give me 10 over 3. So what I'm saying here is my new equation will be 4m cubed over 3 minus m to the power 4 over 4 minus 10 over 3 is equals to 0. Let's use GDC. So use GDC to solve for m. So I'm going to use GDC to solve for m. All right. So let me take it to the left. So if you go to apps, Polysmart, yeah, yep. So here, that will be negative a quarter. Yep. 4 over 3, 0, 0, and negative 10 over 3. So I have two answers. I have 5.24 and I have 1.52. How about these are complex numbers? So no, those are not real solutions. So basically what we have here is two answers. Okay. We have m. So we have m is equals to 1.52 or m is equals to 5.24. Now, because if you look at the question, you can say that the values of x are between 0 and 2, which means that the mean has to be between that boundary. The mean has to be between 0 and 2. So basically, this will be the mean, because the mean has to be between 0 and 2. So that's how you find the median, not the mean, the median. So to find the mod, we know that the mod is basically the value of x at maximum value of f of x. So this is the value of x at maximum value of f of x. So what we need to do is to inspect, find the value of x and maximum value of f of x, and that will be our mod. So you can graph the function. That's another way. and just find the value of x at the maximum value of f of x. So if we do that, if you graph this function, so this is one way of doing it. If you go y is equals to, and just plug in the function, alpha y is equals to 3 over 20 4x squared minus x cubed. So what I'm going to do is just going to change the window.